Hey everyone, thanks for joining me on this lesson. We are going to start out in my home state of New York, home of the Statue of Liberty, the world's best pizza, seriously the best, and the home of the world famous New Year's Eve ball drop at Times Square. Now we are going to go ahead and use Google Earth to take a closer look at the location of Times Square on the island of Manhattan. And now we can see from this map that the roads in New York City make a grid network of interlocking streets and avenues. Notice that our streets run somewhat horizontally and that they are all parallel to each other, and we should know that parallel lines never intersect. We should also notice that our avenues run somewhat vertical, and they intersect our streets in a way that makes them perpendicular or that they form right angles. And looking at the map this way should help us to better understand why, for the most part, Manhattan utilizes a grid system. Now notice that Times Square is located along a street that traverses this grid system. Now you have probably heard of this street before. It's called Broadway. And Broadway is unique because it does not run parallel to any of the other streets on the grid. And when parallel lines are cut by transversals, like in the case of the street map, we have some very unique and characteristic angle relationships which we are going to go ahead and explore further in this lesson. So let's call an Uber and get out of the city. So now let's go ahead and extend our thinking. We can start out by looking at two parallel lines, and we'll say that CF is parallel to JK, and these parallel lines are cut by a transversal. Now just note that transversals can look a number of different ways. They can even be perpendicular. The point is that the angle relationships will always be the same, no matter how the transversal looks. But for this example, we will look at a transversal that is not perpendicular to the parallel lines. Now, when a transversal crosses through parallel lines, it creates a bunch of angles. And we want to go ahead and explore the relationships between these angles. Now, if we pinpoint on those two sets of angles, we should notice that they look pretty much identical. In fact, if we take our two parallel lines and overlap them on top of each other, we can see that the angle measures for either line are going to be identical. And this is a very important property of parallel lines cut by a transversal. Now, what this relationship tells us is that when we have parallel lines cut by a transversal, we can say that the corresponding angles are congruent. So if our obtuse angle on line CF were 122 degrees, then our obtuse angle on line JK would also be 122 degrees, again because corresponding angles are congruent.
Cool.
Now here comes the cool part. If you know one of those angles, you can find all of the remaining unknown angles. Let's start out with the angles directly opposite or vertical to the angle that we just found, which was 122 degrees. We know that vertical angles are always congruent, so in this case, the angles opposite are also 122 degrees. Okay, I'm cool with that, but how do we find the other angles? Now, we should remember that angles that are linear pairs are supplementary, meaning that they have a sum of 180 degrees. So if one of the angles of our linear pair is 122 degrees, I can find the other unknown angle by asking the question 122 plus what number would equal 180, which is the same as subtracting 122 from 180, whose difference is 58. So now I know that the supplement to 122 degrees is 58 degrees. And again, I know that all corresponding angles are congruent. And I also know that all vertical angles are congruent. So now I have enough information to fill in the measures of all the angles on the diagram. So now let's go ahead and look at another example of parallel lines cut by a transversal. And we'll try to make some generalizations about the relationship between the angles that are formed. So let's just say that we know that one of those purple angles has a measure of 30 degrees. Because we know that corresponding angles are congruent and that vertical angles are congruent, we know that all of the purple angles have a measure of 30 degrees. We also know that all of the orange angles have a measure of 150 degrees because they are linear pairs, meaning they are supplementary. So 180 minus 30 is equal to 150. And again, this should really drive home the fact that if you know one of those angles, you can find all of the angles. Now, since we are all about visual learning here at Mashup Math, I want to share with you guys something that I call the X's and O's mindset.
Ooh.
This is a helpful little technique for you to better understand the relationship between the angles in any situation involving parallel lines cut by a transversal. Now, this mindset involves differentiating between the obtuse angles and the acute angles using some kind of a diagonal mark. So in this case, I have a diagonal orange streak for the obtuse angles and a diagonal purple streak for the acute angles. Next, I'm going to label all of the acute angles with the letter X and all of the obtuse angles with the letter O. Now again, you can reverse this and make the acute angles O's and the obtuse angles X's as long as you are consistent. This mindset method will still work. Now, with this visualization in mind, we can conclude that all the angles labeled with an X are congruent to each other, all the angles labeled with an O are congruent to each other, and any combination of an X and an O angle will have a sum of 180. So any XO combo represents a linear pair. So now let's go ahead and apply this XO mindset to an example question involving some algebraic expressions. So in this example, we want to find the value of X and find the angle measure of all of the angles in the diagram. So in this case, we'll label our obtuse angles with X's and our acute angles with O's. And remember those angle relationships. Now in this case, we can see that our two algebraic expressions are both O's. So I know that I have to set them equal to each other since those two angles are congruent. And now all we have to do is solve. We can subtract X on the left side of the equation and subtract 26 on the right side. We can simplify and come to a solution that X has a value of 6. Now we are not finished here. In order to find the angle measures, we have to substitute 6 back into each expression. Doing that gets us an angle measure of 38 degrees for all of the acute angles, the O's, and subtracting that from 180 gives us 142, which is the measure of all of the obtuse angles, and now we have completed the entire diagram. So you may choose to use the XO method or some similar color coordinating method to better help you visualize the relationship between the angles that are formed when we have parallel lines cut by a transversal. So go ahead and use any method that you would like and try this problem on your own, and be sure to share your solution in the comments below. I'd love to hear what you guys get and see what you're thinking. Alright, thank you so much for stopping by. Quick reminder here, click that link below and subscribe to our YouTube channel. We add new lessons every week and I'm sure you want to be kept up to date. And speaking of being kept up to date, make sure that you sign up for our mailing list. There's a link in the description and also on this screen. We send out a weekly newsletter that shares free teacher worksheets, exclusive lessons, behind the scenes stuff, and we have some cool contests and giveaways as well. And also my weekly blog post is featured on that newsletter as well. And we don't want you to miss out, so please go ahead and sign up. It's totally free. You're not going to regret it. And we'll catch you all next time. Again, thank you for the support. We'll see you soon.